Okay, welcome back. Today we're going to discuss reference angles and how they relate to trigonometry in the coordinate plane. So the first thing we need to do is, if we're going to discuss reference angles, we need to talk about what in the world they mean. So reference angle is an acute angle formed by the terminal side of an angle along with the x-axis. So let's take a look real quick at just a visual of that as it really kind of drives home its purpose. So let's say we have an angle in standard form, of course. Here's my initial side. We'll call the angle theta. And here's my terminal side. Okay. So this angle is the angle in question. In this case, it appears to be obtuse. It's larger than 90 degrees. The reference angle is simply the angle using the x-axis and the terminal side of the angle, such that the reference angle is acute, and we mark that with a little prime symbol indicating this is the angle theta, and theta prime is its reference angle. Now, what is it used for? Well, it's used to evaluate trig functions. So the idea is, if we're given a piece of information regarding a angle such that it gives us a location within the plane, we can use that in order to determine the trigonometric ratios of that angle itself. But if you think about back to our original definition of trigonometry, trigonometry came from, and these ratios were developed from, a right triangle, and the trig ratios were developed based on these acute angles only. Now, we've already kind of expanded that and included all angles, but we really haven't discussed why it is the case, or how come we can do that without destroying the triangles that we have. And the reference angles are the basis of that idea. If we have an angle theta that is larger than 90 degrees, well, we no longer can take a point on the terminal side, define a x and a y, and have an angle that is acute. So what we use instead of the angle itself is actually its reference angle. So it's still that acute angle. It still creates that right triangle that we can then develop our ratios from. So we can do a lot with that. For example, let's say we are given the following pieces of information. Let's say we are told that the tangent of theta is negative 5/4. And we know that the cosine of theta is greater than 1. Okay, so we have some angle that we really don't know anything about. All we know is that the tangent of theta is negative 5/4, and the cosine is, I'm sorry, not greater than 1. That's impossible. Greater than 0. Cosine's never greater than 1 because the largest x value on the unit circle is 1. So it can't go any higher. We'll get to that tomorrow. Anyhow, where were we? Yes. So we have the tangent value that we know is negative. We have a cosine value that in this case we know is positive. So in order to make tangent negative, that's sine over cosine. There's only two ways for that to happen. Either sine is negative while cosine is positive, or cosine is negative while sine is positive. Well, this piece of information here tells me that cosine is greater than 0. So cosine is positive. So if we think of the plane, we can first identify what quadrant this is in. So this angle theta begins in the standard position, rotates about counterclockwise, and ends with a tangent value that is negative, cosine value that is positive. Well, the only way for tangent to be negative while cosine is positive would be for sine to be negative, since tangent is sine over cosine. So the question is, which quadrant has a sine value that is negative while the cosine value is positive? Well, that means y is negative, so we know we're below the x-axis, and x, cosine, is positive, so we're to the right. So we know we are in quadrant 4. And now I can kind of give this a little sketch. So the angle theta, starting in standard position, must end somewhere in this quadrant. So theta now we can sketch as an angle in standard position. Very roughly sketched, but that's where it is. Now, what we can do with that is we can say, well, where is its reference angle? Well, it has to be the acute angle connected or created out of the terminal side of this angle along with the x-axis. So here's theta. Now's where it gets fun. If, let's say, we wanted to find, let's say the question is, find sine theta and secant theta. Two values we do not know, because right now all we know is that the tangent of theta is negative 5 fourths. Well, we know that there's an xy coordinate here at this point. And we'll find it here in just 1 second. But before we do that, let's go ahead and draw in a right triangle. Now let's think about what tangent means. Tangent of a function, or tangent of an angle, is opposite over adjacent. So if I look at this triangle, here is this angle, this reference angle to my theta. The opposite must be 5 units, while the adjacent must be 4 units, or some combination of an equivalent ratio. So we'll assume it's just the simplest form, as that makes it the easiest. So opposite, which would be here, is 5, and adjacent would be 4. Well, I'm in the fourth quadrant, therefore this 5 downward we refer to as negative 5. Well, these are just the x and y components of a coordinate. So this coordinate in xy, as an xy pair would be 4, negative 5. Well, that can help me find my sine and my secant. Because if I have two values, or two sides of a right triangle, I can always use Pythagorean theorem to find the missing side. So our c squared equals 4 squared plus 5 squared, or negative 5 squared rather. So 16 and 25 give us c squared. So 30, 41 equals c squared. So c is the square root of 41. So what I now have is this right triangle that instead of using theta, which turned out to be, well, but somewhere between 270 degrees and 360 degrees, or 3 pi over 2 and 2 pi, so a very large angle, we can use its reference angle instead and have this triangle, essentially. Now, we don't know what theta is, we don't know what theta prime is, its reference angle, but what we do know is the ratios of the sides of a right angle created by this must follow the same rules as any other right triangle. So sine would be opposite over hypotenuse, so that would be 5 over negative 41, or I'm sorry, we're in the fourth quadrant, so that would be negative 5 over the square root of 41, while secant would be the reciprocal of cosine. So before I find secant, let me just go ahead and find cosine, that way I know what to flip over. Cosine is the adjacent, 4 over hypotenuse, square root of 41. So the reciprocal of that would have to be secant, the square root of 41 over 4. So these reference angles allow us to calculate out the values of any other trig function based on the use of right triangles. So it allows us to go from angles that are larger than 90 degrees back to this place, this nice setup that gets us back to our very beginning of trigonometry. We have the sides of a right triangle, we have acute angles, and we can apply the acute angles of a right triangle to a non-acute angle by using the reference angles instead of the angles that are given. Okay. Your assignment for the day. Is right here. Please work together. Do your best on that. We're applying all these trig pieces, and we will pick up there next time.